Hey everybody, welcome to topic number 6. Let's review what we so-called the operations of rational expression. So the word rational, I mentioned this word before, means the word fraction. Okay, the word rational just a fancy way of saying the word fraction. So a rational expression is an expression that can be expressed as a fraction, which consists of polynomial divided by polynomial. So a rational expression got to be a polynomial divided by a polynomial. Okay, that's what's considered as a rational expression. So as you can recall, the denominator of any fraction or rational expression cannot equal to 0. Otherwise, it will be considered as undefined. So anything divided by 0, for example, let me do like 4 divided by 2, for example. 4 divided by 2 can be written as 4 over 2, or it can be written as a long division, right? The numerator or the dividend goes in the inside, denominator or the divisor goes on the outside. So we know 4 divided by 2 in long division is written this way. So we know 2 will go into 4 2 times. Another way of saying the same thing is 2 times what number up here equal to this 4, right? 2 times what number equal to 4? Gotta be 2, right? 2 times 2 is equal to this 4 in the inside. So my remainder is 0. So if I was give you the same thing except changing my divisor into a 0, which is 4 over 0. So when I write it as a long division, 0 divisor goes on the outside, dividend goes on the inside. So I'm asking the same question. 0 times what number up here will equal to 4? 0 times what number equal to a 4? Well, 0 times anything is 0, not equal to 4. Therefore, you cannot find this number times by 0 will ever equal to this dividend. That's the reason why anything divided by 0 is considered as undefined. Okay, you can't find an answer. You cannot find a number times by 0 is equal to your dividend. Okay, so denominator over the divisor can never ever equal to 0. Otherwise, the whole entire rational expression will become undefined. So this example here, I want to show you how to find what we so-called the restrictions on the variable. That means what x cannot be. Okay, what x cannot be, because those number for x's will make the whole denominator become 0, which then the whole thing becomes undefined. Okay, what x cannot be. So all you do is set the denominator not equal to 0. Oops, Lord, what's going on here? Set a denominator not equal to 0. Let me do it down here. And solve for x. So this exponent is a square, right? So this is considered as a quadratic equation. There are 5 different ways to solve a quadratic equation, which we'll review in the next topic. One of the method of solving quadratic equation is by factoring. So my left side here is a trinomial. So if I factor this trinomial first, for this 1x squared, I will use 1 and 1, or x and x. For 12, what times what is 12? Well, 1 times 12, 2 times 6, 3 times 4. I'm going to use 3 and 4 first. So currently my outer, the two outside number multiplied together. 1 times 4 is 4. My inner, 3 times 1 is 3. 4 and 3 combined can give me a 1 if I subtract. So when the last sign of a trinomial is negative, the in and outer got to be subtract to get the middle term. The signs in the two parentheses will be 1 positive, 1 negative. Since my middle term is a positive 1, I got to give this positive to the bigger of the two in and outer. So the outer got to be positive 4, the inner got to be a negative 3. So to get a positive 4 on the outer, that will be 1 times positive 4. All right, inner is negative. So once you factored it, right, still not equal to 0. Once you factored it, then we will set each factor that contains the variable x not equal to 0 and solve for x. All right, so I'm going to move the negative 3 and the positive 4 over to the other side. So one of my x cannot equal to positive 3, and the other x cannot equal to negative 4. Because these two numbers, if I plug in these two numbers into my denominator, it will make the denominator equal to 0. Then the whole thing becomes undefined. All right. So later on the semester, this restrictions on the variable will change names. We will actually call this the restriction on the domain. Okay, that's what we will call it later on. All right. So when it comes to simplifying rational expressions, we got to make sure when we simplifying rational expression or reducing fraction, we got to make sure the numerator and the denominator must be one term over one term. Okay, before I can cancel out top and bottom. Okay, so consider the following rational expression. In your own words, what can the x squared and the negative please just cancel out? Where my answer would just be positive 4x. Well, because the numerator right now has 3 terms, the denominator has 2 terms, so they cannot cancel each other out until my numerator and denominators are one term over one term. Okay, before I can cancel things out. So the way how we simplify rational expression is to factor first. Because factoring, when we factor, all our answer is written in multiplication form, right? Between the two parentheses, like up here, between the two parentheses is a multiplication. So that means my answer is only one term. So I basically made 3 terms into a 1 term by factoring. So before I can cancel things out top and bottom, I have to factor numerator and denominator first before I can factor. Okay, so factor the numerator and denominator. So let's do this on the side here. So the x squared minus a 3x minus 4, if I factor that. For x squared, I use x and x. For 4, I will use 1 and 4 this time. Because I cannot use 2 and 2, because 2 and 2 combined will not give me a 3 in the middle. So right now, my outer 1 times 4 is 4. My inner 1 times x, or 1 times 1, is 1. 4 and 1 combined will be a 3 if I subtract. Okay, which is what I did. When the last sign is negative, the 2 signs in the parenthesis will be 1 positive, 1 negative. Since my middle term is a negative 3, I will give the negative to the bigger of the 2 inner and outer. So the outer need to be a negative 4, so that will be 1 times negative 4, the inner positive 1x. So my numerator factored out to be x plus 1 times x minus 4 over. The denominator here is a difference of squares because I got 2 perfectly square terms. And with a subtraction sign in the middle. So before x squared was squared, it was x and x. Before 1 was ever squared, it must be 1 and 1. 1 positive, 1 negative. All right, so just by looking at the factors, so now it's 1 term over 1 term because all these multiplication between the parentheses. All right, what factor will be canceled out top and bottom? I think I can cancel out the what? X plus 1. So once I cancel out the x plus 1, what's left is x minus 4 over x plus 1. I'm dropping the parenthesis because there's no other factors on the top or bottom, so I don't have to have the parenthesis. Okay, so this is how we actually reduce rational expression to the lowest term. Factor first, then see what factor can be canceled out, then we cancel them out. All right, let's factor this numerator and denominator here again. So x squared plus x minus 12. For 1x squared, I will again use 1x and 1x. For 12 this time, using 3 and 4. So currently my outer is 1 times 4 is 4. Inner 3 times 1 is 3. 4 and 3 combined can give me a 1 if I subtract, right? Last sign tells me how to get to the middle term. When the last sign is negative, the 2 signs in the parentheses is 1 positive, 1 negative. Since my middle term is a positive 1x, I gotta give this positive to the bigger of the 2 inner and outer because I need more positive than negative to end up with a positive 1. So the outer, as you can see, need to be a positive 4. So that'll be 1 times positive 4 back here. And the inner negative 3 times 1, negative 3. So that's x minus 3 times x plus 4. All right, the x squared plus ax plus 16. X squared using x and x. 16, 4 times 4 is 16, 4 and 4, right? First so outer is 4, inner is 4. 1 times 4 is 4, 4 times 1 is 4. 4 and 4 combined will be an 8 in the middle if I add. So when the last sign of the trinomial is positive, the signs in the parentheses is either plus plus or minus minus. Since my middle term is a positive, then both of my inner and outer got to be positive. So that's x plus 4 times x plus 4. So the factor that will cancel got to be the x plus 4. One side of x plus 4 will cancel out. So once I cancel them out, my answer, x minus 3 over x plus 4. All right. Now, when it comes to multiplying, okay, when it comes to multiplying rational expression, which again, is just like reducing fractions, we got to factor first, make sure everybody's one term over one term before I can reduce them. Once I reduce them, all I'm going to do is simply write the answer, write down what's left over. I'm not actually going to multiply anything out. All right, so let's factor some of these. X squared plus 4x minus 5. I'm going to do this on the side. All right, find all the factor of my first term, 1x squared, so that'll be 1x and 1x. All the factor of my last term, 5, is 1 and 5. My outer right now is 5. My inner 1 times x is 1. 5 and 1 combined will be a 4 if I subtract. All right, so when the last sign is a negative, the two signs in the parentheses is one positive, one negative. Since my middle term is a positive 4, I gotta give this positive to the bigger of the two inner and outer, because I need more positive than negative to subtract to end up with a positive 4. So as you can see, the outer need to be a positive 5 by 1 times positive 5. So this is negative. Okay, I'm gonna keep my fraction, okay? X minus 1 times x plus 5 over. If you look at this denominator, once again, this is a difference of squares, because 4 and 1 both perfectly square, so that give me a hint. That's what I'm looking for. So before 4x squared was ever squared, it must be 2x and 2x. Before 1 was squared, it must be 1 and 1, 1 positive, 1 negative. Times 2x minus 1, there's nothing to be factored out. This is not a trinomial, not factoring by grouping, right? Not difference of squares. So there's nothing to factor other than 1. So I will put the 2x minus 1 in the parenthesis to illustrate I have factored out a 1. Okay, very important. Same thing with the x plus 5, nothing to factor out other than 1. So I put x plus 5 in the parenthesis to illustrate I factor out a 1 in front of it. So if I look between top and bottom, the factors that will cancel out, I see the x plus 5 can cancel out. I see the 2x minus 1 can also cancel out. So what I got left with on the top is simply x minus 1 over 2x plus 3. There you go. This is how we actually multiply rational expression. Just factor and reduce. When it comes to dividing fraction, division of a fraction means we will times the reciprocal. Okay, so maybe I'll give you an example. Maybe if I got 3 over 4 divided by 7 over, let's say, 8. Division of a fraction means we will times the reciprocal. So the first fraction stays the same. It's the second fraction I got to flip. Bottom go to the top, top go to the bottom. So once I write it as a multiplication of two fractions, then I can reduce top and bottom. Right? So my answer is 6 over 7. Same thing here. I cannot reduce until I write my problem as times the reciprocal. So here, simply let's factor the top and bottom first. 2x squared plus x minus 6. All right, no greatest common factor. So to find the so the factor that will factor my first term, 2x squared, gotta be 1x and 2x. All right, 6 on the back. 6 is 2 times 3. I cannot put the 2 with the 2. That gave me a greatest common factor. So naturally, the 2 go with the 1, the 3 go with the 2. So currently, my outer 1 times 3 is 3. My inner 2 times 2 is 4. 3 and 4 combined will be a 1 in the middle if I subtract. All right, since the last sign is negative, the two signs in the parentheses, one positive, one negative. Because my middle term is a positive 1, then I gotta get this positive to the bigger of the two in and outer. Because I need more positive than negative to combine to end up with a positive 1. So the outer got to be -3 by 1 times -3 by here. This is positive for the inner. Put x and exit back in, back behind 1 and 2. So here I should get x plus 2 times 2x minus 3 over x squared minus 1, once again, is a difference of squares. So before x squared was ever squared, it was x and x. Before 1 was ever squared, it must be 1 and 1. 1 parenthesis plus, 1 parenthesis minus. Divided by x squared minus 4, once again, is a difference of squares. So that's x plus 2 times x minus 2, right? X squared plus 2x plus 1, that's a trinomial. So for the 1 on the back, I gotta use 1 and 1. For the x squared up front, I gotta use x and x. So my outer is 1x, my inner is 1x. 1x and 1x combined will be 2x. So since the last term is positive, the two signs in the parentheses is either plus plus or minus minus. So I will use plus this time because my middle term is a positive. So once I factored, then I will write my expression as times the reciprocal. So the first rational expression stays the same. Then we say times the reciprocal. So the second fraction will flip. The x plus 1s will go to the top. The plus 2 minus 2 will go to the bottom. All right, let's look. What factor will cancel out? The plus 2 will cancel out. The one sets of plus 1 will cancel out. Okay, so that's it. So the factor that are left on the top will be 2x minus 3, x plus 1 over x minus 1, x minus 2 in the bottom. There you go. All right. So when it comes to add and subtract rational expressions, let me bring back topic number 1. I believe we reviewed this a little bit. Toward the end of topic number 1. All right, when it comes to add and subtract, okay, we got to find the least common denominator. So back then I was saying the least common, most people just know what the LCD is, right? So here I'm gonna show you how we can find the least common denominator, okay? Which what we're gonna do here, before I can add and subtract, I gotta find the LCD, okay? So all I'm gonna do is factor each denominator, then count the repeated factor, the non-repeated factors, okay? That's what my LCD is, repeated factor and non-repeated factor between the two denominator. Then I'm gonna find the equivalent numerator using the new LCD, then simplify the numerators. Okay, so let's give this a try. Find the LCD. Let's factor the two denominators first. So for this 4, here I'm gonna use x and x, 2 and 2, right? Because outer is 2, inner is 2. 2 and 2 combined will be 4 in the middle. Both of these got to be positive. X squared minus 4, there's a difference of squares, so that's x plus 2 times x minus 2. So when it comes to counting the LCD, we will count the repeated factor between the two denominator. The x plus 2 repeated, count that one time. This x plus 2 did not repeat, count it one time. This x minus 2 did not repeat with the yellow denominator, we count it one time. So this is my LCD. Okay, now I'm gonna kind of erase some of these markings, okay? So now it comes the tricky part. Which, why don't I give you this example that I just showed you? Let me see, back in topic number 1, right? What was that? 2/3 minus 3 over 2. 2/3 minus 3 over 2. We know the LCD between 3 and 2 is a 6, right? Once we multiply them. Let's say we do not multiply them. Let's say we don't multiply them. Just call them LCD 3 and 2. So I'm gonna write as one big denominator. So this is the way how I'm gonna say it, okay? What does, so I'm gonna write down LCD. What does the LCD has that the first denominator do not have? In other words, the first denominator need to multiply how much to become the new LCD. So you can just kind of compare and contrast. What does LCD have that the first denominator do not have? The first denominator is missing a 2. So we take that 2 times my numerator, which is already a 2, minus. What does LCD has that the second denominator is missing? The second denominator is missing a 3 compared to the LCD. So we take that, so we take what's missing times the numerator, which is a 3. Okay, so that's how we're gonna write it out here. So if you look closely, if you look at your LCD compared to your first denominator, so I'm looking at right here and right here. What does LCD has that the first denominator do not have? Well, if you compare the first denominator with the LCD, the first denominator is missing x minus 2. So I'm gonna take that x minus 2 times my numerator of the first fraction, which is a 6, minus 2 times, right? The numerator is 2. If you look at the LCD versus your second denominator, what does your LCD has that the second denominator is missing? The second denominator is missing an extra x plus 2. So I take that extra x plus 2 times my numerator, which is a negative 2. Whole thing over the LCD, plus 2, minus 2. Okay, now I'm gonna simplify this numerator. Okay, so distribute the 6, the negative 2. I should have 6 times x is 6x. 6 times negative 2 is negative 12. Negative 2 times x is negative 2x. Negative 2 times positive 2 is negative 4. You know what? Let me do this on the side here. Let me write it down here, okay? 6 times x minus 2 times x plus 2. Okay, I'm gonna go ahead and combine like term. I'm gonna do this work on the side here. It's probably easier. All right, 6x minus 2x is 4x. All right, negative 12 minus 4 is negative 16. So at the moment, this is my numerator. My denominator is plus 2, minus 2. Okay, so sometimes the numerator and the denominator answer sometimes the numerator answer can be reduced with the denominator. So let's check this out. This is not always necessary step, but sometimes here I need to check. Between 4x and negative 16, I can factor out a 4. That should leave me with x minus 4. So if I write my numerator as 4 times x minus 4 up here, which cannot cancel with anybody down here, right? So I don't need to do any canceling. So here I can just say my final answer is 4x squared minus 16. Okay, I do the extra step just to see if it can be canceled out. There you go. All right, so for this problem we just did, okay, after you factor the denominators, after I factor denominators, okay, number one, in order to find the LCD, how do we go about counting the factors? How do I go about counting them? And the way we count them is by what? We count the what? Repeated factor, the non-repeated factor to find the LCD. Okay, so that's discussion number 2. All right, so there is actually something I want to show you here. So when it comes to combining a whole number with a fraction, I want to show you this real quick. What is considered as a mixed number? A mixed number like 2 1/3. A mixed number is actually by definition a whole number plus a fraction. So when it comes to convert mixed number into an improper fraction, we normally take the denominator times the whole number, and then we plus the numerator. So 3 times 2 is 6. 6 plus a 1 on top is 7. So 2 1/3 is 7 over 3. Just so if 2 1/3 is 7 over 3, then 2 1/3 is 2 plus 1/3. That means whenever I'm combining a whole number with a fraction, I can always use trick, which is taking the denominator times a whole number, then add on to the numerator. I can use that trick every time when I combine fraction with a whole number. So for this example, I can take my denominator, 2x minus 1, times the numerator, 4. Okay, denominator, 2 terms, right? Representing one denominator, times my whole number, 4. Then I'm going to add to my numerator, which is 3. LCD doesn't change, still 2x minus 1. There you go. All right, so that's what number 1 says. This is a very powerful technique. It shortens a lot of steps. Now I will simplify the numerator. So let's do this here on the side real quick. So distribute the 4. So that should give me 8x minus 4 plus 3, which we know this is going to be 8x minus 1. So my numerator turned out to be 8x minus 1 over 2x minus 1. So this is a 2 term on top over 2 term in the bottom. They are not the same factor, so you cannot cancel it out. So this would be my answer. Okay, so we quickly talked a little bit about how we can multiply, how we reduce rational expression by factoring them, multiply dividing rational expression by factoring, then cancel things out, and we did a little bit of add and subtract. So question number 1 and number 2 on the homework is coming straight from the definition. A rational expression is an expression that can be expressed as a fraction, which consists of polynomial divided by polynomial. The numerator denominator must be one term over one term when we actually reducing the rational expression. All right. So question number 3 is a division of two rational expressions. So please follow the hint. Factor both numerator and denominator first. Okay. Then number 2, we will enter as times the reciprocal. And number 3, simply tell me the factor that will cancel out. Question number 3 is an addition of two rational expressions. So find the LCD first between these two denominators and then start counting what does the LCD have that the first denominator do not have. And that's how much you will increase by. Okay, so that will be the answer for number 2. Simplify the numerators. Okay, and then that will be all. I don't think you can I don't think you need to factor the numerator once you simplify it because I don't think anything can be reduced. And of course, question number 6, I want you to take the denominator x minus 6 times the whole number x, and then add on to 9. So the answer will look something like this, and you simplify the numerator. Okay, so thank you so much for for reviewing operations of rational expression with me. Thank you for watching.